Okay, now let's apply vector addition by standard addition method, reminding ourselves what it means to have a vector placed in standard position. Let's add the two following force vectors. 2.0 newtons, 40 degrees, north of east. The second vector, 4.0 newtons, 50 degrees, south of east. Let's place those in standard vector position. Our 2 newtons will be in this location here, with our 40-degree angle in this position. Our 4 newton vector will be located here, with our 50-degree angle right here. Let's remind ourselves that every vector can be thought of as having an x-coordinate and a y-coordinate. The 2 newton vector will have this x-coordinate and will have this y-coordinate. The 4 newton vector will have this x-coordinate and this y-coordinate. Let's use our sines and cosines to get the x's and y's and fill in our xy table below. We'll record 2.0 newtons here and 4.0 newtons here. And we will be taking the sum of our x's and y's. Let's start with our 2 newton vector. The cosine of 40 is equal to x over 2.0. The sine of 40 is equal to y over 2.0. We will record those answers in our table below. X is equal to 1.5. Y is equal to 1.3. Let's do likewise for our 4 newton vector. Cosine of 50 is equal to x over 4.0. The sine of 50 is equal to y over 4.0. Let's record those answers in the table below. X is equal to 2.6. Y is equal to 3.1. Now we need to assign our positives and negatives to each vector component. The 2 newton vector is pointing in the north of east direction. This is our positive quadrant. Therefore, in the table below, we will keep it as a positive x and a positive y. The southeast quadrant, however, is the negative quadrant, meaning y would then have a negative value, but the x would be positive. Our next step then is to summarize the x values and the y values. 1.5 plus 2.6 is equal to 4.1. 1.3 plus a negative 3.1 is a negative 1.8. Now the sums are equal to the x and y components of the resultant vector. Remember, we will be then drawing a parallelogram here. And the resultant vector will be from this position out to where those two sides meet of the parallelogram. Since the diagonal is a vector, it will also have x and y coordinates with it. 4.1 is the x coordinate, negative 1.8 is the y coordinate. For clarity's sake, I've chosen to write the diagonal all by itself. Here is the x value. This one would be the y value. Let's record that now. The x would be 4.1. The y value will be negative 1.8. Our job now is to find the resultant vector, which would be the hypotenuse of this triangle, and is equal to the magnitude of the vector. And we also need to find the resultant vector's angle. We will use the Pythagorean theorem to find the resultant vector r. That would equal the square root of 4.1 squared plus a 1.8 squared. Notice once again, I am not using a negative value because the square of a negative would be a positive number. The resultant value is 4.5 newtons. Notice again, there's a magnitude of 4.5 with a unit of newtons. Now we need to find the angle theta. One more time, we will use the inverse tangent. We say the tangent of the angle theta is equal to the opposite over adjacent, or the y over x. That would be 1.8 divided by 4.1. We are again finding the angle that this ratio would be true for. The angle theta is going to equal 24 degrees. Now we need to find the reference, south, north, east, or west, for this vector. We look at the sums, or the coordinates, of that resultant vector. We see that there's a positive 4.1 and a negative 1.8. So we always go back to the sum of x and sum of y in order to find the reference for that angle. A negative y and a positive x is the southeast quadrant. I will now write south of east next to my angle. One more time, we have 4 items for this vector: a magnitude with a unit and an angle with a proper reference label.